Hi everybody. So in this video we're going to continue with chapter 14, specifically 14.2 integration by parts. So here we have example 14.7 and they ask us to evaluate the integral of x cosine of x dx. So let's try to use u substitution and make u equal to x. So the derivative of u would be dx, but then what do we do with cosine? Likewise, if we say that u is equal to cosine of x, du, or derivative of u, would equal minus sine of x dx. And notice that this is not to be found anywhere. So how do we approach this? Well, what we use is integration by parts. And integration by parts is something that is derived from differentiation, from what we know as the product rule. Recall that the product rule says that the derivative of u times v is equal to v times the derivative of u plus u times the derivative of v. And if we integrate both sides of this equation, let's do that next. We'll integrate both sides of the equation. So we integrate on the left and we integrate on the right-hand side. Notice that we can write them as separate integrals. Okay, but what is the integral of the derivative of uv? Well, that's just going to be uv. So uv is equal to the integral of v du plus the integral of u dv. So notice that now we can rearrange this equation and we can rewrite it as the integral of u dv is equal to u times v minus the integral of v du. So this is the rule that we're going to use for integration by parts. Very well, so now we're going to evaluate the integral of x cosine x dx. Let's recall that the rule says that the integral of u times derivative of v is u times v minus the integral of v du. So we need to identify u and derivative of v in order to apply integration by parts. For this, there is a general rule that we need to apply, and it has to do with identifying u and derivative of v. So in general, if we need to find a u that is not too difficult to differentiate, and for derivative of v, an expression that is easy to integrate. So in this case, either one is easy, but let's just choose for x as u, and then we can use cosine of x dx as derivative of v. So u would be x, and then derivative of v, we can say is cosine of x dx. Since u is equal to x, that implies that the derivative of u would be equal to the derivative of x, or dx. And then we need to find v, which would be the integral or the integration of cosine of x dx. But that's easy because we know that that is simply going to be that v is equal to sine of x. And now we're ready to substitute inside the formula. Notice that we need u, which is x. So we can actually write that the integral of x times cosine of x dx is equal to, again, x, because that's u, right, times v, which is sine of x, minus the integral of v, which is sine of x, and then du, which is dx. And then this simply becomes x times sine of x minus, and the integral of sine of x would be negative cosine of x plus c. So this ends up being x sine of x plus cosine of x plus the constant c. Don't forget the constant c. Very well, so next we're going to work with example 14.8. And it says evaluate. So notice that here to the right, we have the rule for differentiation by parts. So let's start with a, which is the integral of x times e to the minus x dx. So remember that the first difficulty is choosing what's going to be u and what's going to be dv, but here it's pretty obvious because it's easier to integrate e to the minus x. So if we write that u is equal to x, then derivative of u will be dx. And then if we have that the derivative of v is e to the minus x dx, then a v, which is just the integration of that, will be minus e to the minus x. But why minus? Well, if you look at the derivative of v, right, if we do the derivative, we would need that negative, we have to do the derivative of negative x, which is minus 1, and it's going to make it positive, as you can see here to the left. Okay, so now we're ready to plug everything into the equation and solve. So we have then that the integral of of x times e to the minus x dx is going to equal, remember it's u times v, so x times, and it's negative, so we put it in the front, e to the minus x, minus the integral of v, which again is minus e to the minus x, and then du, which is simply going to be dx. But notice that we have to make this positive because negative times negative is positive, right? If we have a negative in front of the integral and a negative in front of e to the minus x. And then here, from this, we obtain that this is equal to minus x times e to the minus x plus the integration of this part. Now be careful because remember that the integration of this is minus e to the minus x. And then we would have to add plus c. So why minus e to the minus x? Well, because notice that if we do the derivative of this, we get that. So this is the antiderivative of this. And then finally, we can write this as minus x times e to the minus x minus e to the minus x plus c. And that would be good enough. But in some textbooks, you might find that they factor out this expression. And perhaps it could be written as minus e to the minus x times x plus 1. And don't forget the constant. Very well. So now we're going to do b. And it's the integral of natural logarithm of x dx. So there's no direct integral of natural logarithm of x. So here, what we're going to do is that since it's easier to do the derivative of natural logarithm of x, we will make that equal to u. Again, because it's easier to differentiate. Okay, so let's go with u is equal to natural logarithm of x. Therefore, du would be 1 over x dx. And then we can say that derivative of v is dx. Therefore, v is simply going to be x. And now we're ready to plug everything in. So we have that the integral of natural logarithm of x dx is going to equal natural logarithm of x, which is u, times v. But normally you're going to find the x not written after, but before. So you'll see it as x times natural logarithm of x. Then we have that this minus the integral of v again, so x times du, which would be 1 over x dx. So we're almost done, because notice that we can cancel out the x's and we have 1 dx. So this would be then x natural logarithm of x minus the integration of 1, which is simply x. And then finally, we can't forget plus c. Okay, so now we are going to do example C, which is the integral of x squared natural logarithm of x dx. Okay, so here again, when we want to decide what's u, so u is equal to natural logarithm of x, and our dv, or derivative of v, would be x squared dx. Then we have that derivative of u would be 1 over x dx, and then v is going to be the integration of derivative of v, which is simply x cubed over 3. So now we have everything we need to plug into the formula of integration by parts. So that means that we have that the integral of x squared natural logarithm of x dx is equal to, we have u times v, but we're going to put x cubed in front, so x cubed over 3. Start with that, times the natural logarithm of x minus the integral of v du, so v is x cubed over 3, and du is 1 over x dx. Again, here we can cancel out 1x. So notice that this expression to the right would be the same as saying minus 1/3 if we take out the constant, times the integral of x squared dx. So the final step would be, or almost final step, would be that this is equal to x cubed over 3, natural logarithm of x, minus 1/3. Yeah, the minus is important there. X cubed over 3, and plus c, of course. Okay, and then finally we get x cubed over 3, natural logarithm of x, minus x cubed over 9, plus c. We could have also factored out x cubed over 3, but in this case I didn't do it. Okay, so next we are on example 14.9, and it says evaluate the integral of x squared sine of x dx. So it's easier to make sine of x dx the derivative of v, and x squared, we can make it u. So the derivative of u is going to be 2x dx. And then if we have that the derivative of v is sine of x dx, then the integration of that, which is v, is going to be minus cosine of x. So now we're ready to plug everything in. Then we have noticed that the integral of x squared sine of x dx is going to equal u times v. So that's going to be x squared times negative cosine of x, so we put the negative in front. Okay, so now we have this minus the integral of v again, which is minus cosine of x, times du, which would be 2x dx. But notice that we can reorganize this because we have 2x, or the 2, and we have the minus times minus, which can become plus, and we put the 2 outside of the integral. And then this just simply becomes plus 2 integral of x cosine of x dx. Okay, but now we have another integral, so we have to apply the integration by parts to this. So let's start by making x equal to u, and then we are going to get that derivative of u will simply be dx. And let's make derivative of v, cosine of x dx, and then v, which is the integral, is simply going to be sine of x. So let's solve this, what we have here to the right, and applying the integration by parts. We have u times v, which is going to be x times sine of x minus the integral of v sine of x times du, which is dx. Okay, so we can now solve for this, and this is going to be x sine of x minus the integral of sine, which is negative cosine, so I'll make this plus cosine of x plus c. Okay. One thing we mustn't forget is that we have a 2 in front of the original integral, so we have to multiply everything by 2, and this is going to give us 2x sine of x plus 2 cosine of x plus 2c. But this is unnecessary because 2c is just a constant, so we can just write it as c. Okay, and we have the solution now for the whole problem. Because we have then that the integral of x squared sine of x dx is going to be minus, yes, this first part here, minus x squared cosine of x plus 2x sine of x plus 2 cosine of x, and let's not forget plus c. Okay, so now we're going to do example 14.11 where it says evaluate the integral of cosine of x times e to the x dx. So here we're going to make u equal to e to the x, and then the derivative of u will simply be ex dx. And then we'll say that derivative of v is cosine of x dx. Therefore, v, the integration of this, is simply going to be sine of x. And now we're ready to use integration by parts. So the integral of cosine of x times e to the x dx is going to be u times v, so e to the x times sine of x, minus the integral of v sine of x du, which is e to the x dx. So notice that now we have to integrate this by parts again because there's no direct integration. So again, let's make u e to the x. Derivative of u is simply e to the x dx. And then derivative of v is going to be sine of x dx. Therefore, v would be minus cosine of x. Can't forget that minus. So we have u times v. Let's not forget the negative sign in front of all this. So it's going to be e to the x times negative cosine of x, so we have to put that negative there in front, minus the integral of v du, right? So that's going to be negative cosine of x, but let's just make it positive, cosine of x, and e to the x dx. Okay, so now let's take care of all the signs here. This is going to be plus e to the x cosine of x, and then minus the integral of cosine of x e to the x dx. So notice that we're going through a cycle because this is the same expression that we had at the beginning. But that means that we already have the solution because, oh yeah, don't forget that we also have that in front here. So let's write that as e to the x sine of x. And then what we can do is, because we have an equality here, right, all this is equal to integral of cosine of x e to the x dx. We can grab this part and move it to the other side and just add it. So we're going to get 2 times cosine of x e to the x dx is equal to e to the x times sine of x plus e to the x again, cosine of x. And then notice that we can simply send this to divide the whole expression on the other side of the equality. Then we must not forget to delete the 2 on the other side. And we cannot forget to write plus c, of course, right? The constant. Okay, so notice that we could have also factored out e to the x and 1/2, but we'll just leave it the way it is right now.